I'm Avi Goldfarb. I'm the Rotman Chair in Artificial Intelligence in Healthcare and Professor of Marketing at the Rotman School of Management, University of Toronto. And I'm going to talk to you about the simple economics of artificial intelligence based on my book, Prediction Machines with Ajay Agrawal and Joshua Gans. So Ajay, Joshua, and I are professors at the University of Toronto. I'm proud to be there, and it's a good university. But about 20 years ago, something special happened at the university. And that was the discovery or invention, depending on how you think about it, of a number of technologies that have driven the current excitement around artificial intelligence. And coming through the University of Toronto between 15 and 20 years ago were the future heads of AI research at Facebook, at Apple, at OpenAI, and elsewhere. And very recently, two of those people who were at the University of Toronto 15 years ago, one Jeff Hinton, who's still here, won the Turing Award, which you can think about it as the Nobel Prize in computer science. Now, the way the university usually works is I sit in the management department, I sit in the business school. I'd open up the virtual or real school newspaper, see, oh, wow, look at the exciting stuff going on in the computer science department, and then leave it at that and go about my daily business. But Jay Joshua and I run this organization called the Creative Destruction Lab, which is a program for helping science-based startups scale. In our very first year in that Creative Destruction Lab, roughly 10 years ago, we saw a company that called itself an artificial intelligence company for discovering new drugs, pharmaceuticals. Well, that was interesting, a little bit out there. And the next year, we had a couple more companies calling themselves artificial intelligence companies in different fields. And a year later, and 2 years later, we had this flood of companies coming out of largely the computer science department at the University of Toronto and a handful of other schools in Southern Ontario that called themselves artificial intelligence companies in all sorts of different fields. And it was at that point that we realized this is a thing. It's exciting, and it was worth our time to try and get our heads around it using our previous hat of scholars in the economics of technology. And so what this talk is and what the book's about, what our research has been since around 2014, has been trying to understand this change in artificial intelligence and what it means for businesses and other organizations. And the thing that you see over and over again through, this started way back in 2015 and the hypes kept building. And here we are in 2021 and we still see all this hype and excitement around AI. AI adoption is expected to surge. Robots are on the rise. Robots are on the rise, but what does that mean for us humans? We should expect record job losses. Professor Daniel Kahneman, who's a psychologist who won the Nobel Prize in economics, and he said, AI is clearly going to be able to do everything we can do. What's left for us humans? Now, I think it's very important to recognize that there is a particular technology we're talking about when we're talking about artificial intelligence today. It is not like the robots from, say, Star Wars, the droids, who can do just about everything we can do. They do a couple things better than human, depends on the robot. So, for example, C-3PO is a robot in Star Wars. C-3PO can do two things better than human. The first one is something you see in the movie, which is C-3PO can translate between languages better than any human possibly could. The other is less obvious, but it makes actually the droids in Star Wars particularly useful relative to the rest of science fiction, which is that C-3PO listens to humans. And the droids from Star Wars tend to listen to what the humans ask them to do. The rest of science fiction, of course, is filled with these robots who can do just about everything we can do several things better than what we can do, and they don't listen to us. And that's how you get Skynet from the Terminator, or the robots from the Matrix, or HAL from 2001: A Space Odyssey. I don't think this idea of an artificial general intelligence is crazy. I used to think it was, but then I heard a handful of debates and discussions between Professor Kahneman and Jan LeCun and some others that convinced me that this is possible someday. But it's important to recognize that artificial general intelligence has been 20 to 50 years away since the very first AI conference at Dartmouth College in 1956, and it continues to be 20 to 50 years away. This is not the technology we're talking about today. The reason we have the hype about artificial intelligence today is because of a very particular technology, a branch of computer science and a branch of computational statistics called machine learning has gotten much better. And so when you're trying to understand the impact of AI and how it's going to affect your work in your organization, you need to recognize that AI is prediction technology. What do we mean by prediction? It's using information you have to generate information you don't have. That's what's changed. Prediction has gotten better, faster, cheaper. In order to understand why it's a big deal that prediction technology or any technology has gotten better, faster, cheaper, it's worth jumping back a generation to 1995. 1995, I was an undergrad in 1995, and it was exciting new technology. It's called the internet. And there was a lot of hype about it. It was the year that the last aspects of the public internet, the NSFnet, were privatized. It was the year that Bill Gates wrote his internet tidal wave email saying to Microsoft, "We missed this technology in the internet. That's the future of computing." And it was the year that Netscape had their IPO, and they were valued at over $1 billion without a nickel in profit. The hype kept building 96, 97, 98, till people stopped talking about the internet as if it was a new technology. They started to describe this thing called a new economy. This is when I was starting grad school, and my professors very aggressively pointed out, no, it's not a new economy. You still need to take your economics courses, and you still need to buy our economics textbooks. What they said, though, is we can understand the impact of this technological change by understanding what's different, what has gotten cheaper. And in the context of the internet, we could see that search had gotten cheaper, communication's gotten cheaper, and copying's gotten cheaper. And once you understand that, you can map out a whole bunch of consequences. For example, cheap copying, what did that mean? It meant that protecting copyright was going to be a big deal, and it was going to be trouble for the music industry in various ways, at least for the music publishers. At the same time, cheap copying meant that we're going to start paying a lot more attention to privacy than we did before. Because once anything you say to anyone, anywhere, can be instantly broadcast to everyone, everywhere around the world, you're going to be a little bit more careful about what you say. So it's not a new economy, but cheap copying transformed the way we can think about the opportunities from digitization from the internet. To jump back another generation and really get your head around this idea that cheap creates all sorts of new opportunities, think about your computer, about the semiconductor. What does your computer really do? Well, feels like a computer does all sorts of things, but really your computer only does one thing. It just does it really, really, really well. Your computer does arithmetic, and we can represent it as a drop in the cost of arithmetic. We're economists, so thinking about things in cost comes naturally to us. But once you start thinking about things in costs, you can recognize, well, when something is cheap, we do it more. Demand curve slope downward. That's economics 101. When arithmetic got cheap, we started to do more arithmetic. At first, we started to use machine arithmetic and good old-fashioned arithmetic problems. For example, in World War II and shortly after, we had cannons. And they shot cannonballs. And it's a really difficult arithmetic problem to figure out where those cannonballs are going to land. The movie Hidden Figures was about these teams of humans whose job was called computer, who figured out the trajectory of things. But then machine arithmetic came along, and we no longer have human computers who are doing the arithmetic and calculating the artillery tables. But we still have plenty of humans in those jobs because the people who could do the arithmetic also were also well suited to interpret the arithmetic. Similarly, in accounting, if you ask an accountant from the 1940s, 50s, and well into the 60s and 70s what they spent their time doing, they spent their time adding. My fellow professors in the accounting department at the business school here at the University of Toronto remember a time when their professors would ask them to open up the phone book, the white pages, to say page 962. And they'd say, okay, this is a column of tens, if not hundreds of numbers. And they'd say, add up those numbers. Why? Well, partly because we professors are like that. But partly there's more to it. The students put up with it. The students put up with it because they knew they would be spending their lives adding up columns of numbers. And so, machine arithmetic came along, and we no longer have accountants who spend their time adding up columns of numbers. Still plenty of accountants around, again, because the people who are good at the arithmetic also happen to be well positioned to leverage that arithmetic for company strategy and tax policy. And so, As arithmetic got cheaper, though, we started to realize there's all sorts of other applications for machine arithmetic. Turns out games are arithmetic. Mail can be reframed as arithmetic. Music, pictures. We used to solve pictures as a chemical problem. Kodak was a chemical company. But with cheap arithmetic, we started to reframe pictures, images, as an arithmetic problem. So that gets us to today's technology. This is a representation of a convolutional neural net. This is one of the technologies underlying the current excitement in AI. You should think about this as cheap prediction. Same graph, different axis. Artificial intelligence, this transformation we've seen over the past few years, we represented as a drop in the cost of prediction. And just like with arithmetic, the first applications are good old-fashioned prediction problems. Right? You walk into a bank and you want a loan. The bank has to predict whether you're going to pay back that loan. Increasingly, banks are using machine learning tools to make those predictions. The insurance industry is also predicting whether you're going to make a claim or not. They used to do it with other sort of old-fashioned statistics, and increasingly they're using these machine learning tools. But as prediction gets cheaper, we're starting to realize a whole bunch of other things can be reframed as prediction problems we didn't think of as prediction problems, like medical diagnosis. Medical diagnosis is prediction. What does your doctor do? They take in data about your symptoms, and they fill in the missing information of the cause of those symptoms. That's prediction, and increasingly, researchers are applying machine learning tools to make better, faster, cheaper diagnosis. And image recognition is prediction. How do you recognize a familiar face? Your eyes take in light signals and fill in the missing information of a label in a context. That's prediction technology, and increasingly machine learning tools, AI, does that as well, if not much better than human. So up until this point, we are on day one of Econ 101. As technology gets cheap, as something gets cheap, we do more of it. This is the idea that demand curves slope downward. The price of something falls, we buy more of it. If coffee is cheap, we buy more coffee. The fears around AI are about substitutes. Yes, as coffee gets cheap, we buy more coffee, but we also buy less tea, because tea and coffee are substitutes. And so to the extent that your job or your organization is focused on human-related prediction, as machine prediction gets better, faster, cheaper, your job in your organization is going to have to change. That's kind of bleak. So what's left? What's left are complements. When coffee gets cheap, yes, we buy less tea, but we buy more cream and sugar. And so the question you should be thinking about for yourself and your organization is, what gets more valuable as prediction gets cheap? What are the cream and sugar? What are those complements to prediction? In order to understand that, you need to know what prediction is for. Prediction is valuable for one reason. It's valuable because it's an input into decision-making. And decision-making is a big deal. A prediction without a decision is useless. The core is to identify decisions and figure out how to insert your skills in your organization into those decisions. Because prediction is not decision-making. What is decision-making? Well, a decision has a whole bunch of parts to it. It has the prediction here at the center, but it also has data that allows you to make a better prediction. It has the judgment, which you can think of as which predictions to make and what to do with those predictions once you have them. And then it has actions and outcomes, which is what happens, what you can do with the combination of prediction and judgment. Let's talk about judgment. There's this movie, I, Robot. It's a fine movie with a fantastic scene. So Will Smith is the protagonist in I, Robot, and he hates robots. So you can kind of figure out where the movie's going to go. Why does he hate robots? There's this flashback scene. Will Smith and a little girl are driving, and there's a car accident. And for whatever reason, they both are sinking in a river. And it's pretty clear that both Will Smith and this little girl are about to drown. Then a robot comes along and saves him and not the girl. And that's why he hates robots. What's interesting is because it's a robot, he could audit the machine. He could figure out, why did the robot save him and not the girl? And what he found is the robot made a prediction. The robot predicted that he had a 45% chance of survival. And that girl only had an 11% chance of survival. And that's why the robot saved him and not the girl. But there's something missing there. That's the prediction. The judgment is to say, well, 45%, Will Smith surviving is better than an 11% chance that that girl survived. Okay, that's the, to the extent that he thinks the robot made the wrong decision, What he's saying is that girl's life is worth more than 4 times his life. Judgment is the reward to a particular action in a particular situation, right? It's the payoffs that you get for making those decisions. And that, for now at least, is inherently human. How does this play out in an organization? How do you think through, okay, well, we have these predictions, we have prediction machines, we're going to insert machine prediction instead of human prediction. We're still going to need lots of humans to judge. How does that all play out? Well, you can think about this as every organization has a workflow, which is a series of tasks and decisions within each job. And what you do is you identify which tasks and which decisions are predictions. And you, to the extent possible, take the machine and replace the human. And so that leads to a more macro, policy level, pessimistic view, which is that, well, there's a whole bunch of things that machines can predict. And eventually machines might even be able to predict what would the human do. And so that means that AIs are going to replace jobs, leaving little for us. Okay? There's a different pessimistic view that says AI is wonderful and influential, but as Bob Gordon of Northwestern University has pointed out, it's not as exciting as the technologies that diffused between 1870 and 1970. AI is great, information technology generally is wonderful, but it's not the flush toilet and it's not antibiotics. Now, Joel Mokyr is another Northwestern professor. He's my history professor a long time ago. And he said, well, the good news is that both of these pessimistic predictions can't be right. And the even better news is that they can both be wrong. We can't both have AIs that massively increase productivity, leaving little for us to do, and AIs that don't matter. It's sort of a one or the other. But we could have AIs that both make our lives much better and give us time and give us the ability to continue to do interesting and new work. So the sort of big policy question number one is this the end of jobs? Well, let me ask, you've seen the movie The Matrix. In the movie The Matrix, every human has a job from the day they're born to the day they die. They're not good jobs. What are humans doing? They're batteries. They're providing energy. Will there be jobs is the wrong question. The major victory of the 20th century in labor was not that we had more work, but that we had less. We got to retire. We got weekends and 8-hour workdays. Will there be jobs? Will there be work is the wrong question. The right question is how, if AIs fulfill their purpose and they massively improve productivity and generate wealth, how will that wealth be distributed? How do we think through? Will a small number of people gain? In which case, yes, maybe on balance, we have more wealth, but we have massive inequality. Or will we think about ways to spread that wealth so that everybody can take advantage of the increase in productivity? Now, moving from society level trade-offs, it's going to increase productivity and to the extent it does that, do we all get to benefit, or do only the people with the right skills and who own the machines get to benefit? Let's now return to how does it increase productivity? What does it mean? What does it look like for a particular organization to change because of prediction? And to ask that question and answer it, and ask you another question, which is, if you wanted to look something up, say 30 years ago, where do you imagine you would have went? For those of you who weren't looking stuff up 30 years ago, try to think through, a previous generation. What would they have done? They wanted to look something up. Well, they might have gone to an encyclopedia, and failing that, they would have gone to a beautiful big building. Might look like this. This is Robarts Library. This is one of the least most imposing buildings on the University of Toronto campus. And if you walked into Robarts Library 30 years ago and walked up to a librarian and said, what do you think the most exciting industries in the world are going to be in 2020? I bet you none of those 1991 librarians or 1992 librarians would have said, you know what? The industry of the future is library science. And yet, it turns out that if you think about what's arguably the most exciting company in the world today, what they're doing, they're a library science company. Google helps you look stuff up. That's what they do. And they do it better and faster and cheaper than used to happen in a library. A librarian might argue not as well, but it turns out once accessing information, once looking stuff up is cheap enough, there's all sorts of commercial opportunities in looking stuff up. We don't have to subsidize the library anymore. We now, the place where you look stuff up, the library can make plenty of money on all sorts of other searches that maybe we wouldn't have subsidized before. It turns out that cheap looking stuff up can replace the library and the yellow pages and the classified ads and do it much more efficiently in ways that there's plenty of money to be made, plenty of revenue. So how do you think about this in the context of your own organization and your own work? What does it mean for AI to make, to transform the way you operate? We like to think of this as a dial. I mean, that's where you can turn up the dial on prediction. And at some point, you're going to turn up that dial enough that you can change the way you operate. For example, here's Amazon's predictions for what you might want to buy. Now, Amazon has hundreds of millions of items in their catalog. And as far as we can tell, they're right something like 1 of every 20 times. That's extraordinary. Think about that. Hundreds of millions of different items. They predict what you're going to buy, and they're right something like 5% of the time. It's extraordinary, but it's actually not transformative to Amazon's business. What do I mean by that? Amazon is in the same business they were in when they started back in the 1990s. And in fact, they're in the same business that the Sears catalog was in well over 100 years ago. Amazon is a catalog company. They're an excellent catalog company, but fundamentally, they're a catalog company. You go to their online catalog, you tell them what you want, they send that information to their warehouse, and they ship it to your door, just like Sears would have done a long time ago. Now, what does it mean for these recommendations, these predictions of what you're going to buy to transform the business? Well, instead of 5%, let's say they were 20% or 50% or 70% accurate. At some point, Amazon can do something totally different. For example, maybe they don't need to wait for you to buy. If their predictions are good enough, it might be worth it for them to just ship it to you. And then you open a box at your door, take what you want, and leave the rest. And Amazon will be selling you so much more stuff because they are getting it to you when you want it, that it's worth it for them to invest in the infrastructure to deal with the 10, 20, 30, 50% of stuff you don't want and to deal with those returns. Now, let me be clear. We have no idea if Amazon's really going to do this or if this is going to be feasible, but we do know they've thought about it. Here's a patent from 2013 for anticipatory package shipping. This idea of moving from shopping on the website in the catalog and shipping to your door to shipping to your door and then shopping as you open the door has been around for a long time. So whatever industry you're in, think about the predictions that happen now and think about what you can do differently as you turn up that dial. As machine prediction gets better in terms of diagnosis, the healthcare industry can change. Maybe you don't need all those years of training of primary care doctors and the selection on your ability to write an MCAT and memorize things. Instead, maybe we need to train our doctors differently. And the whole primary care experience could change from someone who we think of as a doctor to someone who has the skills more like a psychologist or a social worker. We spent a good chunk of 2020 and parts of 2021 inside, looking outside. Why? Because of a prediction problem. We didn't know who was infectious. And because we didn't know who was infectious, we had to treat everybody as if they were infectious. A better prediction on whether a particular individual was infectious or not would allow most of us to just go out about our business as we had before, and those few people who are infectious stay home. Lockdown was a direct consequence of bad prediction. And better, faster, cheaper prediction for, in this case, infectiousness could have transformed the way we lived at that time. So whatever industry you're in, you can run through this experiment. Imagine we get better and better and better at predicting something fundamental to what you do, how does that allow you to do something different? Thank you.